Now let us discuss keys. Normally, keys are the foundation. Keys are the foundation of what we call relational structure. All right, they are the foundation of relational structure. We have already been seeing two very important keys earlier. Excuse me. We have been already seeing two very important keys earlier, which is the primary key and the foreign key in a previous video. And we are going to extend on that when I'm referring to keys, what they are referring to. It means that, first of all, keys help us to identify records uniquely, just like in the context of a primary key. You have keys that helps you to enforce relationships, all right? Of course, the other foreign key. And key also ensures data integrity, where there are no duplicates and you also have consistent records. So what is that? Consistent references? Sorry. What it does is that a key enforces consistency through constraints. The common types of keys that you have, obviously, are primary keys. You have composite keys. You have foreign key as well. And normally we have discussed the primary key, we have discussed the foreign key. We did not really discuss the composite key, but I'll mention that in a moment to explain what this is about. But there are also other common key types that are used, but I'm not going to discuss them in this course. So there is the candidate key. Just give me a second review. Uh, yes, we have candidate. There is something that we call the candidate key. All right. It's a column or a set of columns that could serve as a primary key, basically. But I'm not going to discuss that formally here. I'm just mentioning it just for your knowledge. And then there is something else that we call the alternate key. That's also another type of key that exists. Alternate, excuse me, there's this L missing here. So the alternate key, it's a candidate key that wasn't chosen as a primary key normally, right? There is also the composite key, as I mentioned. There is also something else that we call a surrogate key. Excuse me. Yes, there is also something else that we call a surrogate key as well. The surrogate key is basically like an artificial key, all right? It's an artificial key and often used when no natural keys exist. And you can, for example, there is one common example that you usually use is the auto increment. Generally, if you do not have a specific key already established or defined, you can create a surrogate key for an auto increment, and that will create a surrogate key, which is not necessarily considered as a primary key, but it's an artificial key, and you can also consider it as a primary key if you wish as well. But these are the different types of other keys that exist. You have primary key, composite key, foreign key, candidate key, alternate key, surrogate key. But as I mentioned here, I'm just mentioning these here, but I'm not getting into the details of what these are. We will focus mainly on the three that you are seeing on the screen here: the primary, the composite, and the foreign key. What each of these mean. There are certain examples that we want to discuss. Now we can walk through some of these SQL examples. Just click on that. Here we go. You have different types of keys, and as I mentioned here in this course, I'm focusing only on these three. What is a primary key? As I explained to you, we already discussed it earlier. The primary key is the key that enables you to identify records uniquely. All right, it enables you to identify records uniquely, as you would see here. I mentioned the primary key identifies each record in a table uniquely. There is something else that we call a composite key, and there is something else that we call a foreign key. Let's get back to the primary key for the time being. So here in this example, if you have a table called student, where one of the fields of that table, one of the field of that entity is full name of the student. That is, full name represent an attribute of that entity called student. And then you have a date of birth. That's good. So you have two columns normally, and these two columns in your data will involve the full name and the date of birth. So let me just go back to this example here. You have the full name and the date of birth. So maybe person one is called John Mark, for example, or whatever, date of birth, let's suppose 2001 1980, things like that, and so on and so on. You will have Matthew, whatever, and then you have another date 0108 of 1985, let's suppose, and it goes on like that. So each of these people that you have here, the foreign key called, let's suppose somebody is called Matthew, somebody is called John Mark, you may have somebody else called Matthew as well. And if that somebody else is called Matthew, maybe his date of birth is different. Let's suppose he's born on 20 07 2000, year 2000. Just a second review. I'm just getting a small bug here with yes. If that person is born in year 2000, for example, here, and then if you observe this, there may be two different persons with the same name, for example, with two different date of birth. So we are not referring to the same person, even though they have got the same name, let's suppose in this example here. So, but nevertheless, they can be identified uniquely through what we call a primary key, where, for example, the first person is called number one, the second person is called number two, the third person is called number three. So, three uniquely identifies Matthew of that particular date of birth, and two particularly identify Matthew of that date of birth, and one identify John Mark of that particular date of birth. So basically, here you will see that we have created a unique identifier for each of these different people. So let's get back to the example here. As you see here, the primary key, what it is doing is that it is uniquely identifying each row in that table. On the other hand, you also have a composite key. The composite key, what's the difference between the primary key? In the primary key, as you are observing here, there is only one column that will represent the primary key that identifies uniquely that particular row. But in a composite primary key, you don't have necessarily only one column that identifies a particular row. You might have more than one columns that identify uniquely a particular case, if you want, a particular record. For example, in here, if you talk about employee project, you have the employee ID, excuse me. You have the project ID on which the employee is working. you have the hours worked on that project, and you see that now the primary key is defined as not only one, that is employee ID, or only project ID, no, but it is rather represented through the combination of employee ID and project ID. Why? Because sometimes one person, one employee may be working on different projects. All right. For example, here, let me just come back here. The composite key. You might have, let's suppose, RT is working on. RT is name of the employee. All right. Just give me a second review. Yes, RT is, maybe I won't use RT, I will use an employee ID and a project ID. But let's suppose um, here you have employee ID 1, 2, 3. But apart from employee ID, you would have recalled there is also the project ID. And then you have a number of hours work. Project ID may be P01, suppose P02, etc., etc. So maybe you will see that a employee ID one may be working on different projects. For example, you may be working on PO1, but you might have employee ID1 working on project 2 as well. So now you cannot say that employee ID can represent the primary key because there is duplicate employee IDs. So employee ID cannot be used as a primary key on its own because there are duplicate employee IDs. So, however, if you take the combination of employee ID and project ID, like 1 and PO1, project ID 2, and 1 and PO2, now you get it distinct because 1 PO1 and 1 PO2 are not the same thing. You get a distinct, normally, key, which is referred to as a composite key. So, what is a composite key? As I just mentioned here, the composite key is similar to the primary key principle, but with a combination of more than one or two columns. Just let me open that. So you can easily understand what a composite key is. It's a primary key made up of two or more columns, as I mentioned. So, as I said to you, an employee ID may not be sufficient to work on an employee project. Maybe you might have more than one employees working on a project, or a project is worked on by many employees, and so on. So then you use a combination of these two to create a primary key. Then you have obviously the foreign key. This is the key aspect of a relational database where you have the link that is made between the different tables. Let's suppose you have two tables, create table house, where you have a house ID and the name of the house, where the house ID is a primary key in that house, and then you create another table, and that other table that you create is called room, with a room ID, with a room name, with a house ID connected to that house here. So obviously this house ID relates to that house ID that you have here. In this table here, house, it is referred to as a primary key when we refer to the house ID. But in that particular table, the house ID is not the unique identifier of the room table, but it is an ID that enables these two tables to be linked together. All right. So the house ID that you have here will be the same house ID that you have here. they are linked together. But the link is done through what we call a foreign key. The foreign key is basically what enables these two tables to be linked together. So the foreign key, it basically references a primary key from another table. And our foreign key is house ID, and it references the house ID from the house table. This is how you write it normally. So that's what some of examples of a primary key, foreign key, and so on. So, for example, as I just mentioned, there is a link between house and room. Sorry, yes, room. So the room, let's suppose room ABC is located with respect to a particular house ID. The room ABC here under the room table will be related to the room ABC here from this table house, right? Etc. etc. So that's how we define the foreign key. These are the most important keys. I've already been mentioning that several times in my different videos. Please go through these videos. Please go through these videos again. That's very important. Now let us move to constraints. Let us move to constraints. There are different types of constraints, right? Constraints are basically rules, that my SQL, excuse me. So they are basically rules. They are basically rules that my SQL enforces automatically when you insert, update, or delete data. That's what it is. They are rules that MySQL will normally enforce automatically when you are inserting, updating, or deleting data. So, why constraint matters? Obviously, there are different reasons why constraint matters. I have mentioned here is that they help enforce data integrity automatically. MySQL won't accept any rules that break these, any value that break these rules. There are different types of constraint. The most common one is a not null, all right? Unique, check, default, primary, and foreign key. These two are the two constraints that we have been discussing so far, and it's relatively easy to understand. But we are going to talk mainly about not null, unique, check, and default constraints. The not null states that this column or this field must have a value. Must have a value. So not null does not allow any missing information to be included in the data. It enforces you to have a value in any row of the columns. There is also the unique constraint. The unique constraint, I think the word is easy to understand, is that it does not allow duplicate values. No duplicate values. No duplicate values. It doesn't allow for any duplicate values. So you can check, you can insert a unique constraint if you don't want a person or to input a data twice, the same data twice, for example. There is a check constraint as well. What is a check constraint? It means that the condition that the value must meet. It is a condition that the value must meet. It does not allow you, for example, if I say do not allow a salary less than zero. Do not allow a salary less than zero. You can do that through the check constraint where negative values are not allowed. So it restricts values to meet a condition. That's a check constraint. There is a default constraint. There is a default constraint which basically provides a fallback if none is given. It provides a fallback if no value is given. Let's suppose if I say I don't want to give my salary information, then you can use a default value to include to input a value for salary in your database. This is what we refer to as a um, default constraint. So if, let's suppose, a few people do not want to give salary, you can use default constraint to put a specific salary that will be used at any point in time. And then you have the primary key, which is a combo of not null and unique. And you have a foreign key which references another table. So it points to another table's primary key. This constraint helps keep your data clean and consistent. Through the not null, you will have the opportunity of having a data that does not have many missing values for a column. Through the check constraint, you allow your data set not to be input with inconsistent or un, with inconsistent data. It doesn't allow you to input anything that is inconsistent. Why does constraint matters? Why does constraint matters? Let's say you're building a customer database. What happen if someone forgets to enter a name? All right, you're building a customer database. What happens if someone forgets a name? Or what happens if someone enters the same email twice? All right. What happens if someone uh, enter the same email enter the same email twice? Without constraint, your data can become very messy, inconsistent, and even dangerous, if I can use that word. So with constraint, you are able not to have a situation where a customer name is not available through the not null. So not null enforces the name of a customer to be input in the database. And the check constraint, not the check constraint, because as I mentioned, the unique constraint enables us to ensure that all emails have been input only once, not twice or three times for the same person. So with constraint, what happens is that when you're going to load your data, you will get an error when rules are being violated. If your rule is not following the not null constraint and you have a null information there, it will trigger you a message showing you that there is a problem. So this is basically what I mean by constraint. What are the different types of constraint that you have? So that's the principle of constraint. Having said so, now I can move to normalization. Normalization. Now, what is normalization? It's a bit like, if you want to say it, like the hygiene of a database, if you want. Normalization is basically the process of reorganizing data into multiple related tables. Instead of having a single flat table, let's suppose you are talking about customer records or client records. A person goes on the website and purchase different products. Of course, that person has got different information related to that person. You got the first name of the person, maybe you got the date of birth of the person, maybe you got the phone number, you got the email address, you may have other information related to that person, gender, or whatever it is. And then, apart from the information related to the profile of the individual, you will have the purchased product, the date that the person purchased that product, the price of that product purchased. So imagine here having a single table including all these different information here: the name of an individual, the um, age of an individual, the phone number, the email, and so on, all details pertaining to the profile, and also the different information related to, let's suppose, the product purchased. For example, what date the product was purchased, what date it was delivered, what is the product purchased, whatever, what is the price paid for the product. Imagine having all this in a single table. Now, what does normalization say? Normalization says it's better to break down that big table into several tables that are related with each, that would be related to each other. For example, instead of having a single flat table, it tells you to break down that table, for example, into customer profile as one table, and then you have another table which would be the purchase profile. Let's suppose I just give it a name, purchase profile, and these two will be linked together, obviously, through the key, the concept of key that I explained to you that we call a foreign key. So what does the normalization is saying here is that it's a process of reorganizing data into multiple related tables. For what purpose? It's mainly to reduce duplication. Reduce duplication. That's one of the reasons why you want to normalize. It also ensure logical consistency. Excuse me. It ensures logical consistency. It makes future updates easier. It makes future update easy. Yeah, all these are the different reasons why you organize, why you normalize the data. You normalize into multiple rigid tables, basically to reduce duplication, to ensure logical consistency, to make future updates easier. And we have a series of steps called normal forms. We have a series of steps called normal form. You have the 1NF that we will refer to as the first normal form, the 1NF. You have the second NF and the third NF. So you have the first normal form, you have the second normal form, and you have the third normal forms. All these are, each one eliminates a certain types of problem that you have with regards to a big table. All right. Let's take some example now to illustrate that. The first normal form. What is the first normal form about? It's about having no repeated groups at any point in time within a particular column or anything. It means that all fields means all columns in the table must hold what we call atomic values. Each column should contain atomic values. All right, let me just relate to that what I'm saying here. Each column should contain atomic values, no repeating groups of data. If you look at this example here, you have the order ID, the customer sum, and you have the product pen, pencil, and pad purchase. You will see that here there is a problem with that particular column called product. Why? Because product does not hold an atomic value. What does it mean by product does not hold an atomic value? You will see that products are in free here. It's not like you have a single product. You have multiple products purchased, and in only one column, you have all these multiple products purchased, which is violating the first normal form, because the first normal form state that you should have only one product for one column. That's what it is saying here. It should hold an atomic value. Let's take a look. I click on that. There we go. So if you want to normalize that, you should get something that is similar to that. So instead of having several values in one column, you have now an atomic value for product. It's not, if you look at the view bad table again, before it was pen, pencil, and pad. Now you have in only one record, there is only one product. So you can repeat this order ID here without any problem, the same person Sam, but with different products for different records, but not like in this case here, having several products in only one record because it violates the principle of first normal form. You also have now the second normal form. What is the second normal form? Normally, the second normal form, uh, what it does is that it eliminates what we call partial dependency. To be able to reach that second normal form, you need to have gone through at least the first normal form. That's the first step. When you get to the first normal form, if this is fine, then you move to the second normal form to ensure that your database is normalized. All right. Now, the second normal form, what it does is that it eliminates partial dependency. What does this mean? It means that every non-key column, every non-key column. What is non-key column? For example, here you have customer, product. These are non-key column. Order ID may be considered as a key, for example. Every non-key column must depend on the entire primary key. It must depend on the entire primary key. That's what it means. Let's take a look at this example here. If you look at this table clearly, you will see that there is student ID for course registered, there is course ID, there's course name, and there is primary key. And the primary key in this particular example is a composite primary key. Now, what does the second normal form state? That uh, all the columns that you have should depend on the entire, that is the complete composite primary key in that particular example. If you take course ID and course name, let's talk about course name. Course name, if you are doing, for example, MSc Data Analytics, it does not depend on the ID of the student. It's rather the contrary. The student ID will depend not this will depend on the course that you have, that you have chosen, but not your course name will depend on the student ID. So what is happening here is that the course name depends on the course ID, which is part of the primary key, but the course name does not necessarily depend on student ID, which is also part of the primary key. This is where you have what we call partial dependency, but not complete dependency on that key here. If it was only course ID, which was a primary key, that would have been okay for course name. But given that it's not only course ID, which is a primary key, but course ID and student ID are the primary keys, that's is a primary key. I mean, the combination of these two is a primary key. That's why I cannot say that course name depends on student ID. In other words, there is what we call partial dependency, and if there is partial dependency, that violates the second normal form. So what do I do to have a second normal form? The best thing to do would be to normalize that by creating another table, for example, that would be course. And then you keep a course registered, but you don't need to put the name of the course here. You can keep student ID, you can keep the course ID if you want, but the course name is not necessary. You don't need to put the course name here, you could put it in a different table. Let me just show you that example here. And create a table course. You have a course ID and the course name. So you will see that course name depends fully on course ID. Now there is no problem. This is in the second form. and it also is in the first form because you would not have a column where you can record more than one value, for example. And then here you have another table, which was our original table, where you have the student ID and the course ID, but there's no course name because course name is already part of course here. And then you state your primary key. And of course, if you have stated your primary key, don't forget that you need to link these two tables. The only way to link these two tables together would be through the foreign key, where the course ID is our foreign key. That's what it means by second normal form. You are eliminating what we call partial dependency, just like in this example, where course name was only depending on course ID, but did not depend on student ID. So that's what it is, the second normal form. Now we move on to the third normal form. So just bear in mind, this is the second normal form. Now we move on to the third normal form. The third normal form is about eliminating transitive dependencies. Here we talk about eliminating partial dependency, but here we're talking about transitive dependency. A transitive dependency occurs when a non-key attributes depend on another non-key attribute. That's what um, transitive dependency means. If you look at the department name here, department name is stored in the employee table, but department name does not depend on the employee. But the department name actually depends on department ID, right? It does not depend on employee, but it depends on department ID. So what does it mean? To achieve a third normal form, it is better to put department name depend on the department ID, that is through a different table, rather than having a single table that include all of this. We normalize it by creating a different table for department, where you have department ID and department name. Now department name depends on department ID. It's a transitive uh, dependency. You are eliminating transitive dependency, sorry. And then you have create table employee, where you have the employee ID, you have the employee name. All these are related to that particular table. And of course, you have a department ID, which is here, but you don't need to put the department name, because one way or the other, the employee is related to a department ID, and there is no need to put the name. So then you have, of course, the foreign key. So what happened is that each normal form that you have seen, the first normal form, the second normal form, and the third normal form, they reduce redundancy and improves your data structure. What are the benefits of normalization? Obviously, it is about less duplication. You will see that there is less duplicate application. That's the application, which is about reducing data redundancy. There is improved consistency, that is fewer chances of conflicts in the database. There is also easier maintenance, where you can make changes in only one table and the rest is updated and deleted automatically. If you have to update a customer record, you just need, in the purchase, you remember here, if you, I think I mentioned that earlier, but anyway. So if you have the purchase order here and you have a customer details, if there is an update with regards to a customer detail, it's only the ID of that person will be here, not the full detail of the person. Sorry, for the purchase for the purchase table, there will be only the customer ID rather than the full detail of a customer to update. So only the ID of a customer is updated, and it will automatically be taken into account in the purchase table. That's what it is. And then it also simplify queries, all right, where you can make use of logical joins. You can make use of logical joins and fewer, and it gets fewer anomalies. Then obviously you have the idea of supporting referential integrity, especially through the foreign key. I'm not going to discuss that because I've already been explaining that to you several times before. So the links are defined clearly via foreign key. This ensures referential integrity. But it's also about scalable design. It's also about scalable design where it's easy to extend without breaking logic, easy to extend the database without breaking the logic behind. Think of it a little bit like a long-term planning. It takes a bit more effort early, but saves huge time later. This aspect of normalization. Here we go. Uh, that's all for our fourth lecture. Have a nice evening. Bye bye.